again to this channel. So we have here the topic inferred zero resistance. What is this all about? For further explanation, I have here with you an XY plane represented by resistivity and the temperature for the X and Y axis. The point of intersection is the origin. Now, this curve represents the relationship between the temperature and the resistivity of a material. Let's consider this point, the point where the graph of your material relationship between temperature and resistivity and the vertical axis where it intersect, and name this as rho O. So I will let a line pass through this point, I mean tangent to this point. So this is the line, and this line also will intersect the x-axis, which is the temperature. So for the value of the temperature, I write the big letter T sub O. So this is before the origin. It means that the value of this T sub O is a negative value. So this is what we mean by absolute zero. Normally, when we hear that phrase absolute zero, 273 degrees Celsius negative comes into our mind. So we know that it is before the zero temperature values. Therefore, it is a negative value. But in our materials, we have different absolute temperature value, and we have a table for that. So what did you notice? You notice here we are forming a right triangle that you have here in opposite side and adjacent side and the hypotenuse. Let's consider another point in this line. This point, we name this as point 3, simply as extending the x and y plane. You have here for your temperature as T3 and rho 3 for your resistivity. Again, what did you notice? You formed here a right triangle represented by this red broken line. This is important because we can have relationship between the two triangles. These are similar triangles since they are both right triangle. And writing this relationship, I will use resistance instead of rho or resistivity, because we know that resistance is directly proportional to the resistivity. So instead of writing resistivity, I will write R. Now, the side of this big right triangle is to the side of this small right triangle. So therefore, instead of rho 3, I'll write it as R sub 3. So is to this side. So this is R sub O, which is equals to the adjacent side for the big right triangle, that is actually T sub O. Okay, plus T3. Okay, so actually T sub O here is negative, so we just want the absolute value divided by the adjacent side of the small right triangle. So this is again T sub O, okay, plus TO. So we know here that T sub O is equals to 0 in this figure. So we have here R3 RO, which is equals to the absolute value of T sub O plus T3 divided by negative T sub O absolute value plus 0. So this will be the relationship. Now, we already know that in having two conditions, we are using this formula, R sub 2 is equals to R sub 1 times the quantity 1 plus alpha 1 T sub 2 minus T sub 1. This is the temperature at conditions 1 and 2. So this is again alpha, the temperature coefficient of your material at condition 1. Okay, knowing this one, we can actually substitute this as R2 and R1. So we can say instead of R3, we can say R2 and R1, considering the temperature 1, temperature 2 same as this formula. So therefore, if you are to consider that, this will become again negative T sub O absolute value plus, so since this is temperature 2, we write T sub 2, and again negative T sub O absolute value of that plus, since this is at temperature 1, that is T sub 1. Now if you are going to manipulate this one, so you have here R sub 2, R sub 1, you place it on the left side as denominator, and what remains is 1 plus alpha 1 T sub 2 plus, this is subtraction, minus T sub 1. Okay, so therefore if you are to substitute this equation to here, so it will give you 1 plus alpha 1 T sub 2 minus T sub 1, which is equals to again negative T sub O plus T2 divided by the absolute value of T sub O plus T sub 1. So what we are doing here is we want to get the value of our alpha 1. So you just have an algebraic manipulation of that. So for your alpha 1, actually I will not show it anymore to you how you are going to get the alpha 1 here algebraically. You just perform it with your own. Alpha 1 is actually equal to 1, that will be over negative, the absolute value of negative T sub O, okay, plus T sub 1. Okay, so this formula here is also the temperature coefficient of the material at condition 1 using this relationship. So this is the inferred zero resistance. So therefore, if you know the absolute value of the temperature of your material, you just add it with the temperature in condition 1. That will be your denominator, okay, or inverse of that, and when you press your calculator, it will give you the temperature coefficient. Okay, so this is all about inferred zero resistance. So thank you so much for watching this video. I hope and pray that I add learning to your learning desire. Thank you so much.